Today we're going to talk a little bit about the Hardy Weinberg equation. Now, the main purpose of this equation is to determine the allele frequency in a population. So what we mean by that is we can determine how many genes out there are actually the dominant genes, how many genes are the recessive genes, and then using that information, we can figure out, well, what percentage of the population is going to be homozygous dominant or homozygous recessive or even have a heterozygous genotype. While this may not seem like something that would be useful, we actually do use these in determining the genetic health of a population. And what I mean by that is, think about genetic disorders. People want to know what is their chance of actually being a carrier in a situation for that. And so we can figure out those probabilities using the Hardy Weinberg equation. Now, when we talk about the Hardy Weinberg equation, we're going to talk about any type of trait that has a dominant or a recessive allele, or only two alleles. And for this equation, we are going to say that P is going to equal the frequency of the dominant alleles. Q is going to equal the frequency of recessive alleles, or the percentage of recessive alleles. Since the alleles are either dominant or recessive, the frequency of P plus the frequency of Q would equal 1. Now, that's all fine and dandy, but that doesn't tell us enough. We still want to know what the homozygous percentage is going to be, the heterozygous percentage. And that would be to have a genotype of PP or P squared. A homozygous recessive would be QQ or Q squared. Okay? And so what we're going to have to do is take what we had and actually square it. So if we go back to algebra and we think about this, if I have P plus Q and I square that side, I'd have to square the other side, and I would end up with P squared plus 2PQ plus Q squared equals 1. Where this is the homozygous dominant, we have the homozygous recessive, and this would show us the frequency of the heterozygous trait. Okay? So if we take a look, how are we going to go about solving this problem? First, when we look at a population, the only one that we can actually determine is Q squared, because anyone who shows the recessive trait must be QQ or have two recessive alleles. Then, once we know Q squared, we can solve for Q by taking the square root. If we know both Q and then we can solve for P, because if we plug in whatever we have for Q here, it would just be 1 minus Q to equal P. And then if we know P and Q, we can solve for the rest, because remember, it was just P squared plus 2PQ plus Q squared equals 1. So let's take a look at an example here, if my computer decides to move forward. We'll give it a few more seconds, and if it doesn't move, I'll start a second video. Okay, I'm going to start a second video, and it will have just the example in it.